Hello and welcome to this new episode of the CATIA Talk. So this time we are welcoming Ilkay Jan Standard from GenX, which is based in New York, and to a person which is working with to explain us how she's using CATIA, the generative design aspect, and all her projects, the work that she's doing with CATIA in her company. So this is a very new episode of the CATIA Talk. It's been broadcasted on the CATIA Building and Infrastructure community. This talk is going to present a lot of things about how we're using CATIA. It's pretty new with a champion. And so we're very happy to welcome you, Ilkay. I'm going to leave the floor now to you guys, so you can, be very at ease with showing what you're going to show. And thank you again for being there today. Thank you for taking the time with your fellow employees to present us your projects.
Yeah, thank you so much, Cyril, for having us over. We are excited to show what we do and especially to focus on how we use CATIA with our projects.
Great. Thank you very much.
Of course.
Great.
Of course.
So I'm going to get out of the stream. I'm going to add your presentation. And I think we are good to go. You can present your screen.
Yes, awesome.
See you at the end. Bye.
Thank you. Well, first of all, I'd like to introduce quickly my colleagues joined to the presentation with me, Sezgi and Melike. They helped me with the presentation. They're also helping developing our CATIA standards. We are very excited to be here because we love CATIA. We've been using it for the past few years. It's certainly an application or platform that needs a lot of attention to master. We think that we are on our way to get there. But shortly to talk about GenX, we are a company that wants to focus on tackling the industry problems holistically. And we work from contractors to developers. That gives us a full understanding of issues that arise during any phase of the project. With that said, we are a small team of people based in New York and New Jersey. In Istanbul, we have an office in Istanbul. I worked in the field over 15 years. I used to be working at Computers and Fox as an associate partner, currently running GenX, and I am teaching at NYU, and I work with multiple schools globally as well. And this is to show our offices in New York and Istanbul. We have partners globally. We collaborate, again, globally with the universities as well. We truly believe in getting the best and the most efficient information that can be used on the site as well. So we are trying to bring everyone together in one place. This is to show our projects, some of the samples. I will go through them really quickly just to show scope of works that we do and the scale of the projects we do. That should give you an idea of our own experience. Majority of these projects are done or in progress in 7 different countries. I will quickly go through some of these projects. Crystal Plaza in Shanghai. This is a project I was part of as Computers and Fox teams, actually. Similar to Ziraat Bank, this is in Turkey. Built another project in Dubai, in Mexico. I think this was in Shanghai. Another project in Shanghai. Home Health Center is something I will show today. We are doing fabrication for this building's facade and all the metal panels, actually. And we are doing this in CATIA. So this is a project I will be showing. Another project we are doing fabrication. We work with very cool companies like Virgin Hyperloop. This is a confidential project, as you can imagine, but all these images are from their public website. This is also a place where we are looking forward to use CATIA, as that's going to help us optimize our design process and increase efficiency for workflow design to fabrication. prior projects I showed was architectural projects. Now these are construction projects. We really got a chance to work with really cool projects. That's Pfizer building in Hudson Yards, Google headquarters, Amazon, Apple retail stores, some well-known restaurants like Chop House, Momofuku restaurants. As you can imagine, the mechanical systems being very intricate to coordinate with the layout. We do many other small-scale projects as well. To come to the topic that we are here to talk is, us understanding how we could increase AEC industry's efficiency and tackle understanding its problems, as well as what are the realistic solutions. And our topic is mass customization, as that seems to help us a lot. So the first problem is always the growth of population and the migration to cities. With that, I'm going to run you through like really quick statistics that we are looking into, and that is like understanding population growth next 10 years globally, and expected growth forecast. Previous was population, and we are comparing cities like London to New York here, and their planning and transportation relationships to understand how these existing cities compare. We also look into this a little bit more in detail. We compare New York City, Hong Kong, and London. As you see, the population in three cities are actually pretty close to each other, but in the middle, as you see right here, is their density or population density differs. Their strategy differs, and as per that, their transportation strategy changes. How much of that public, how much of that private, buses, trains, or walking. So these are all things that we have to think holistically to make a sustainable cities and an urban environment for us. Looking at those, we are proposing some solution. The first is, we have to use biomimicry. Biomimicry, as nature is the best and most efficient designer, we have to look and see what solutions that we can bring into our built environment. Looking to trees, the fact that they can stand tall and carry the water to their top, leaves. The repeating shapes for efficiency and the form that repeats in different scale of living things or non-living things. So we think this is part of our solution. Second solution we are proposing is for especially AEC industry, we need to look into other industries. And in this case, we are highlighting there is no difference building an airplane versus a high-rise building or infrastructure, high-speed train. At the end, the design process, analysis, coordination, and then fabrication, installation, this all has to happen pretty much the same sequence. And why can't we use the same technologies? And this is where CATIA comes into play. Of course, with that, if you understand that there are technologies from other industries that we can bring, but also the concepts, right? Looking to assembly line concept here, Henry Ford accomplished, 3 hours producing a car in 3 hours versus 3 weeks. So if we could increase our efficiency in construction environment, and which we are, there are many modular construction companies looking to make this happen, being able to organize or build things together in factories or offsite to increase that, decrease that assembly on site, as that lowers many issues. So with that, this is our topic of interest that we are trying to solve. I'm coming to a different board here. What I want to do here is I want to show our projects in CATIA that addressing some of those issues that I mentioned, especially modular construction in this case. But I also want to show the fact that currently there are multiple new startup companies and long-term companies like Autodesk and Dassault here, what stages of the project that they are able to be used, and the length that we could use them. Obviously, this new startup companies, they are changing. We did this, I think, last year. They may be doing a little bit more, but right now, as you see, the most comprehensive concept to digital operation can be managed within 3DEXPERIENCE platform by Dassault, and we want to be able to show some of these examples. So this is the typical phases, I guess. Globally, we could all agree this is how construction happens. So there's no rocket science there. But what we see is how we could use conceptual design phase to actually make majority of the designs, so the flow to fabrication is more seamless. With that said, I'm going to show, we put some of our videos here, but I'm going to show a few of them, specifically how we are using CATIA in this area. In this case, I will open this video here. If I can manage to do this, I'm going to grow this right here. Perfect. Okay, so in this project, or in this video, what we are showing is using multiple applications from CATIA and Natural Sketch, one of them. As you see, we have a building 3D modeled. During coordination, you're able to link your 2D, in this case, CAD drawings. And then you could just draw your sketches, make markups. Those are just like basic lines, but those lines are vector-based and they could be translated into actual walls. So this workflow you see, we are working with 3D view. It can also be used with AR or VR. At the bottom, you see there's an option. So multiple people can actually be in this view, in this model, and start adding their markups and do their nodes. From that, you're able to turn those into model elements. Another conceptual level example, which I love to show, is we are using a Natural Sketch app within an actual scaled 3D model. It's a site model. Architects are, adding that art and soul, the atmosphere of the project. So we need those tools that gives us more artistic views. This is almost working in Photoshop or Illustrator. We are able to add these vector-based lines and sketches to create a concept. And then we are able to pick the lines that we like, that creates our boundary for our design. In this case, we picked a generic form of the building and the podium, and we open that in generative design. I'm going to stop this here for a second to show that we're able to add parameters to control. You see that we still have our sketch that controls our geometry in general, but as you see, we also have floor levels. So we are able to add, maybe multiple different levels for retail, office, residential. There are different heights and even the top heights. We're able to control that parametrically and visualize the output, how many square foot we are getting, what is the surface and efficiency rate for these floors. As you see, we open the monitor tool here, which shows us, all those data the way we want to see it. Another thing I want to highlight here that in generative design, you're able to create multiple versions of one design. So you could change using the same parameters, but different values. You're able to test and compare next to each other how your design benefits or how it look differently if you were to change some of those parameters. And the coolest thing is when you go back to your original Natural Sketch diagram or drawings that we did, and we start manipulating that, that will reflect back in our parametric design. And this is pretty much doesn't exist in any other application the way it is here. I'm sure most architects appreciate that as a workflow. In this category where we are showing the conceptual design, there's another good example here that I can show. So basically here we are looking to a facade paneling system, triangulation of a rather curvy surfaces. We were inspired by Frank Gehry projects, I guess. So as you see, we are creating panelization on the surface. We want to use triangles, and from that, we are able to manipulate the size of those, and then we assign a color categorization in a way that it will show us which panels are in the range of the sizes that we want to keep versus if we want to change them or they're out of our scale in the sense that maybe we need to change our panel sizes to get back to what we need. Here, if you have seen, actually, we use attractive point. Let me go back here. So this is similar in a way that you would use Grasshopper, right? We add this attractive points, so as you move it, it will increase the solid or glazing areas. So not everything has to be super calculated. So there's that room for coincidental design, which is, I know, extremely important for architects. We don't want things to be just results of mathematics, right? We want them to be some elements of natural decision making, just because that does contribute to the level of design. And here you saw that we created our triangle panel as our units, and then instantiate that into our model. As you see, the model is very detailed, and there is a room where we could manually change the panels. As you see, we are doing that. Like, we want this to be glazing, or we want that to be metal, that we are able to change that if that's needed or wanted for specific reasons, like through coordination or something. So this is just showing the process of creating our final product, from concept level to pretty much detailed in a way that we could create our fabrication drawings from these panels. All right. So moving into more detailed work for design development. This is actually, since we continued with a little bit more facade work, let me show the facades project we have here. Let me open this up as well. So the concept here I want to show is the fact that CATIA allows us to create this driving geometry, a parametric model that we use as base our main model for more detailed information. And even though they are separate from each other, the driving geometry, when it changes, or detailed model reflects accordingly. So this is kind of a video that kind of shows that. As you see, we are creating a surface for our building using generative nodes. We are creating, dividing our panels to create our grid system. And we are creating our UDF using scripts to instantiate our panels to the surface that we divided originally. And as you see, when we manipulate our geometry, driving geometry on the right side, or left side model, detailed model, responds to that accordingly. So this is a workflow that I know most architects and contractors in need of, just because you want to be able to manipulate and make decisions quickly. You don't want to waste time, or you don't want to afraid making changes for the betterment of the project down the road, because it's just too late to make those changes, and the schedule will be tight. I'm hoping that this proves that point, that that's doable. So when it comes to looking into modular construction, This is a kind of case study. We work with MBBJ, Tim Johnson, where we developed an idea of how to produce a modular building that is not just a tower, a cube, but that could fit into any geometry. To start with those, though, we looked into the fact that how can we be more generic and generative with our workflow. That being said, we are creating a parametric outline, as you see here, that controls basically how our layout for the modular units, but also the number of core elements that we have is controlled by completely the size of the site. As per that, it decides if needs to have a double corridor, if it has to have a central courtyard, and how many cores it needs to have. And you will see that as it gets smaller, the core drop to 1, and it made the most efficient layout as per our parameters that we have given. This is also, we got support from James Cotronis helping us modeling this still modular unit that we could instantiate into our model. That shows that from concept to detail level, we can go really fast. Again, here we are using this natural sketch tool, designing and adding an atmosphere and understanding the design implications of developing a concept. In this case, we are using a curve that we want to fit our modular units under as efficiently as possible. And as you see on the left side, when we manipulate the concept model, it will reflect back to our very detailed model as well. So zooming out a little bit to show you that we covered this portion and we have a couple more to go. So another really cool project, which I want to get a little bit more in detail is, actually, before I get into this, maybe I can finish up the modular concept. So I just show you a modular building built with steel modular units. And we looked into the idea of how can we make the same concept with timber elements. As you see, this is a unit we modeled down to, bolts and every single item. With that, we use that. Let me open this up. I'm just going to skip the first portion as this is showing our typical units, the design concept a bit on the modular construction. Sorry, I'm not able to skip this. I guess I'm not. Okay, previously we showed, we actually looked into this a little bit more detail than mentioned. We tried to optimize all items here. And from that, you know what, I don't think this is the right video actually. Okay, I'm gonna skip that. Coming back to our tower project that we developed a facade system in CATIA. So let's scroll through this. The important thing to mention here, architect, the Biskin Studio, they give us their Rhino model and they continue working Rhino model. So what we did here is using their Rhino model as our basis and without changing anything, we just used that as our surfaces and massing model. We apply grids and panels on it directly onto the Rhino model itself. Here you will see that we are actually inserting the levels through Excel file. So that has the Excels, and we split the surface as per the dimensions we were given. And as you see, we have width, height, and spandrel offsets. From here, we are analyzing the surface to see, by using this division rules, how many non-typical conditions we have and what are the opportunities to avoid this or minimize non-typical conditions. By using the color coding, you're able to see it. And these are all the mullion types we have in the building. So we model them individually, and they are smart enough to respond to changes of the facade. I will show you shortly how we achieved that through automation. But basically, the challenge in this project was that the glazing surfaces will change angles, and even though our mullion stays flat or parallel to the ground, the nib that holds the glass will change its angle, and this demonstrates that. And obviously very tricky corner conditions. Here we are showing that once we change our driving geometry, the instantiated or the panels instantiated updates itself. So what we are showing here, again, I will explain this a little bit more in detail, is how we use automation to actually instantiate the correct mullion types and correct panel types. We will get into this in detail, but what you're seeing here is we pick this panel here and run the automation. With automation, it highlighted this yellow panels. Those are the panels that are surrounding our panel that we are studying right now. And as you see, there are corners highlighted. Again, those are identified corners. They are different colors because it shows they're up, down, or side panels. Based on the angles that it calculates on the corners, for example, this is that angle is bigger, it recognizes as a corner condition and applies the panel accordingly. So this shows all the panels that came as a result of that instantiation through automation. And this is showing one of the floors. All the complex shop drawings can be extracted out of this. And as you see, the geometry is really clean, especially at the corners where it was difficult to do so. Another thing to highlight with CATIA you could do is project management. This is something we really like. There are tools that you can mark up in the where you work, and then you can assign to the people or your teammates, and they will notify it and get, you could respond to them accordingly, which supports the idea of remote working and global working, in the sense that we don't really have to be in the same room to be able to coordinate something so complex. Coming back to the beginning of the project, where we look into the instantiation and analysis, and see if there is going back to the original division to see if we need to do any further optimization on the system. So that being said, the areas of where we use CATIA kind of mentioned and show modular construction. We went through these videos. The second one is building design. We show one tower, and we will actually open this file to show you and infrastructure projects. So getting into the detail of this again, what I just showed, I want to give a little bit more information on how we set up the file and how we create our panels and how automation worked through that. I am sure those who are starting new or has been using it would appreciate our way of doing this. Maybe you can have comments for us as well. As mentioned, we bring our original models from Rhino. We extracted the plates, though we use Excel file actually to create our levels in XGenerative or in CATIA, but we also have a surface model. We use XGenerative tool to create our panel surfaces individually, and we were also able to do analysis in XGen to see typical, non-typical conditions. And then we are using building engineering tool to create our different type of panels. As you see, there are many different type of conditions that happens because of the folding of the surfaces and straight and slanted areas. Once we create and identify different type of panels we need, we work with the using our surfaces or divide the surfaces and the panels. We instantiate them in assembly design, and from that we create our detailed panels coming here. So getting a little bit more in detail here, for the panels, we are able to create lists of items to categorize our information, right? We want to split the surfaces to left, typical, and right conditions on the surfaces as basis to start. Those split into further actually as spandrel glazing versus glazing, and from that we also define non-typical conditions by looking at what kind of geometries we have created or results from the geometry of the building, and those are triangle and some multi-corner panels. And then lastly, we have corner mullions, which are changing angles and changes profiles because inward or outward conditions. So this was also automatically done, which I will actually showcase here. In this case, in the previous video, I show how our nib condition changes as per the surface angle, whereas our mullions stay perpendicular the whole time. So that was a challenging design feature, as simple as it sounds, that we had to test. I have a quick video here showing how we apply our corner mullion. So we created this left and right side of the corner, and using our sketch here, and it's responding to design changes, angle changes of the corner. And then we just pick the two edges that defines the corner angle, and then it automatically places that. As you see, we are adding it here. It actually adds that mullion and responds to the geometry really beautifully. So that shows our mullion application. Here, I'm going to try to explain the automation. This is a little complicated in the sense that actually it has been a while since we did this project, so hopefully I will remember enough to explain it correctly. But basically, I mentioned that we organized and list the panel surfaces as per left, typical, right. Those are the most occurring panel types. And then we divide them a second level of glazing and spandrel because they have different panels, basically. And then here we are using the ECAL script to apply types and edges. I think there's an error coming, but not from somewhere. Is this cool? No, that's a mistake. And it helps us with automation. What it helps us is to choose the right type of parts in the right surfaces. So here what we are showcasing is these are some of the type of panels that we have identified through automation. What it does is it marks its corner conditions and counts how many corners there are. And it counts how many corners on one edge. Actually, what it does is it extracts the boundary of the panel and explodes the boundary. I think this is a better example to show, or maybe let me show it here. Like it defines the fact that there is right edge. This is the right edge of this panel, and from extraction of this line of the panel and disassembling it, meaning that this is one line here, a second line here, instead of one continuous line. It knows that this is two separate parts. With that, it knows that these two parts are on the right side of the panel, and it instantiates the right panel Boolean here. It knows that this is the bottom and the top and the left one. It also will know that on the left side, if there's another Boolean or surface in an angle, it will know that it's not the left Boolean, but rather corner Boolean. So this is pretty smart and automation that we think can be further developed and used in multiple different applications as well. So just quickly going through the questions that we ask, it asks whether this bottom Boolean exists. If no, then we eliminate that or replace a metal panel instead. If it is yes, we looked into the length of that. If the length is less than a certain amount, that's we turn that into a metal panel instead of glazing. And then that question of understanding the surface itself helps us define which Boolean type or panel type should be applied there. That being said, I think I wrapped up our project here.